In question number 6, it is stated that the normal distribution mu is 30 and sigma is 5. Find a point that has 15% area below it. In the figure, A is on the left tail and the 15% area, which is equal to 0.15, is below this point. So we will write it as probability x less than A is equal to 0.15. Now x will be converted into the z-score, and z is obtained by the standardized expression a minus mu. In our case, mu is 30, so we will write it here 30 and divided by sigma, and its sigma is 5. So we will write it here, the expression of the standardized variate is equal to 15%, which is equal to 0.15. Now, whenever there is probability that less than, we can write it as capital phi. So we will write it here. It's capital phi of the expression, this one, a minus 30 divided by 5. So phi of this expression is equal to 0.15. Now phi is on the left side. Whenever it goes on the right side, we have to take the inverse of phi inverse of the point probability, which is 0.15. For phi inverse, we will have a table 10a. So using this table, and look in the column under the probability p, 0.15, and it's here under the 0, its value is minus 1.0364. So we will write it here. Its value is minus 1.0364. So A will be solved from here. A is equal to 30 plus 5 multiplied by this expression minus 1.0364. This equation will be solved for the value of A, and A is equal to 30 plus 5 into minus 1.0364. Its answer is obtained from here, which is equal to 24.818. From the figure, we can observe that 30 is in the middle, the mean of the distribution. A is on the left side and 24 is less than 30. So this is the result of the A at this point. Below this point, the area is 15%. Now in the next part of the question, they are asked to find a point that has 28% area above it. So from the figure, the point A is on the right tail, and above this point the shaded area is 28%, which is equal to 0.28. So the remaining area on the left tail is 1 minus 0.28, because the table gives us the area from minus infinity to that point A. and its value will be obtained from 1 minus 0.28. But we are given probability x greater than a is equal to 0.28. The above area from a point is 0.28. So in this, we can write it again, and 1 minus subtract 1 minus from each side, we will have 1 minus 0.828, which is equal to 0.72, and this sign will be reverse. X less than, now we can write it as x less than a is equal to 0.72. Probability x less than a, now we will convert x normal variate into z standardized normal variate. Z less than, and this value will be obtained a minus mu, which is equal to 30, divided by its sigma, which is 5, and this expression is equal to 0.72. Now we can write it as capital Phi of a minus 30 over 5. And this expression is equal to 0.72. And we can write it as phi inverse of 0.72, and this value exists in the table 10a. This is 0.72, but we have to write it there. It's phi inverse because it's now on the right hand side. From the left it comes to the right hand side, and the table value from 10a, it's on the next page. Yes, third last line. The answer is 0.5828. 0.5828. And now we'll solve this equation to get the value of a, which is obtained 30 plus 5 into 0.5828. Its answer is 32.914. 0. Its answer is 32.914. From the figure in the center, it's 30, and the A is on the right side. So 32 is definitely more than 30. So it is verified that A is 32.914. Two points. Now we have to find the 2 points in the normal distribution with mean 30 and standard deviation 5, and these 2 points containing middle 95% area. Middle 95% area means that both points are equidistant from the center. A and B are the 2 points on the number line X normal variate, and these 2 points are equidistant from the center, and correspondingly on the scale there are 2 points on the scale corresponding to A and B, and between these 2 points area is 95%. So we can write it here, the area is 95%, which is shaded by the green color. So probability can be written in this way: A to X up to B is equal to 0.95. and the probability is in the center of the curve, which occurs here and denoted by the green color shaded area. So this is the 0.95 area, and beyond this shaded area, we have 5% area which is on the both tails. Half of the area of 5% on the left tail, and half of the 5% is on the right tail, which is equal to 0.025 on each side. We have given the table phi of Z1 for the area for 0.025 on the left side, and we can get the value of Z1, and correspondingly we can calculate the value of A. To calculate the B point here on the right tail, we have to calculate Z2 first using the area below this point, which is 0.025 plus 0.95. So adding these two probabilities, we will get this arrow line, which is equal to 0.975. And using this probability, we can get this phi of Z2. And using phi of Z2, we can get the area, the point B on the number line, random variable X. So for this, for obtaining A and B, we use three areas under the curve. First one is on the left tail, which is minus infinity to A, then plus area A to B, then plus area B to plus infinity. And all three are adding to 1. So we can write it as probability X less than A plus probability X A to B lies between A to B plus probability X greater than B. All three are written as equal to 1, because these three probabilities are actually in the portion of the whole area under the curve. Now we are writing the given probability, which is 0.95, and we are substituting this value here equal to 1, and then 0.95 comes to the right hand side, and its answer is now 0.05. And on the left side, probability X less than A, the left tail area with this one, and probability X greater than B, which shows the area on the right tail. So by adding these two probabilities, we will have the sum 0.05, and both are the equal parts of the curve. So half portion of this 0.05 is for probability X less than A, and half portion of this probability is for X greater than B. Now we will write these in two equations. First, probability X less than A is 0.05 divided by 2, and other equation is as probability X greater than B is equal to 0.05 by 2. Both are giving us 0.025. So we will convert X normal variate into the standardized variate, and its value A is its standardized value, which is A minus 30 over 5. So probability Z less than standardized value A minus 30 by 5 is equal to 0.025. And the other equation, we have seen that there is the greater than sign. So we will subtract 1 from both sides, left hand side and right hand side. We are subtracting 1 from each side. And this equation, 1 minus the greater area, X greater than B, will give us the probability X less than this one, X less than B. And 1 minus 0.025 gives us 0.975. This 0.975 area is shown by
the blue arrow starting from minus infinity up to the B. So the area is 0.975. Now we can use the phi table, area table, and obtain this point Z2 and then correspondingly B. This probability z less than is can be written as phi of this area is equal to 0.025, and 1 minus phi, in other equation 1 minus probability x greater than b is equal to 0.975 can be written as probability x less than b, and this x is now converted into the standardized variable z, and b is converted its standardized value b minus 30 by 5, and probability z less than b can be written in the form of phi. So in this equation we can write it as phi of this point is equal to 0.975, and the other equation we are taking this phi on the right side, so phi inverse, and using the phi inverse table, which is table 10a. So using this table we can observe the value of 0.025. This is the quantiles of the standard normal distribution table 10a, and zp is equal to phi inverse of p. We have given the probability 0.025, and phi inverse of 0.025 is observed from the column under the caption P, and 0.025, this is 0.02, and 5 is under the column 5. This one answer is minus 1.96. We can observe the value from here is 0.96 under the column minus 1.96, and the same value for the 0.975. So for this we will use the other page. 0.975 is not here on third page, and the third last line is 0.975, which shows under the column 5 its value is plus 1.96. So using both values um, in our solution, we can obtain the results. From the table, we can write phi inverse is 0.025, and phi inverse of 0.975 is 1.96, and phi inverse of 0.025 is minus 1.96. So using these two values in the equations, we can get the value of A and B. A is 20.2 and B is 39.8. So we can check, verify that these two values are on the left tail and right tail, and median, the mean median mode is 30. So mu is 30, which is in the center, and 20 is on the left side, and 39 is on the right side, the value of B. So it is verified from the figure that these two results are correct. Next is question number 6b. The time required by nurse to inject a shot of penicillin has been observed to be normally distributed with mu 30 seconds and sigma 10 seconds. Find the 10th percentile. 10th percentile occurs on the left tail. The area from minus infinity to a point A is 0.10, and this shaded area is denoted by phi of C, and Z is the point corresponding to this A point on the Z scale. So we can write it here. Probability x less than A is given as 0.10. We will convert it probability Z, capital Z less than A minus mu, and mu is given as 30 divided by sigma, and it is given as 10. So this probability is written as 0.10, and probability z less than any specified value can be written in the form of phi. So we will write it as capital Phi of point A minus 30 over 10 is equal to 0.1, and phi inverse can be obtained from the table. We will write it here, phi, not this one, capital Phi inverse, because it is now on the other side of the equal sign, so we will write it as 0.1, and from the table, phi inverse table, which is 10a, we will observe from table phi inverse of p, the value of 0.1 is here, and its value is minus 1.2816. So substitute this value, minus 1.2816, and solve this equation for the value of a. So a will be 30 plus 10 multiplied by minus 1.2816, and the result will be obtained as 17.18. As 30 is in the middle of the curve and a is below this 30, so its answer would be 17.184. Similarly, we can get the 90th percentile, and 90th percentile would be on the right tail. So the shaded area will be increased, and it will be now, for example, the point is now here, and the whole shaded area starting from minus infinity to this point will be included, and this shaded area is as 0.9, and we will solve the same pattern to get the point, and the probability will be used as 0.9. That whole shaded area is 0.9, and this point, for example, in our case it is B, and the corresponding value is on the Z scale is, for example, Z2. So we can get the point B, which is the 90th percentile. We can write it as P90. This is the 90th percentile. And we will use 0.10 instead. We will write 0.9 instead of 0.10. And we will observe the value from the figure, that its value is 0.9 on the third page. 0.9 is here, 1.2816, but now it's in positive sign. So we can write it here and with plus sign and obtain the 90th percentile. Thank you for watching video. Allah Hafiz.